Experience has shown that a certain lie detector will show a positive reading 10% of the time when a person is telling the truth, and 95% of the time when a person is lying. Suppose that a random sample of 5 suspects is subjected to a lie detector test regarding a recent one-person crime. The probability of observing no positive readings if all suspects plead innocent and are telling the truth. Okay, let's try to figure out exactly what this is asking. Okay, 5 suspects. And we have 2 probabilities, the 10% and the 95%. Okay, so the lie detector will show a positive reading 10% of the time when the person is telling the truth. Okay, so probability of a positive reading given that they're telling the truth is 10%, so that's a conditional probability. And then 95% when a person is lying. So the probability of a positive result given that the person is lying is 0.95. Okay, so we've got 2 conditional probabilities there. Can I move just that? Yeah. Okay. The probability of observing no positive readings if all suspects plead innocent and are telling the truth. So that's the probability of a negative reading given that the person is telling the truth. Okay. All right. Well, if a person tells the truth, there's a 10% chance of a positive reading, which would imply there's a 90% chance of a negative reading. Okay. Positive, negative are complementary outcomes, right? So their probabilities have to add up to 100%. Right. Or you can think of it this way, right? The suspect is either lying or telling the truth. And then the lie detector test is either positive or negative. Okay. We don't know how often people lie or tell the truth. Okay. But we know that when somebody is lying, 95% of the time, there'll be a positive result, which would imply 5% of the time a negative result. Okay. And when somebody's telling the truth, right over here, 10% of the time, there'll be a positive result, which means 90% of the time a negative result. Okay. So like the thinking I was doing here was just equivalent to this part of the tree diagram. Okay. So now I know that if it's one suspect, there's a 90% probability of getting a negative result, so not positive, if the person is telling the truth, but there's 5 suspects. Okay. So I need to find the probability of the first suspect having a negative result while telling the truth, and the second suspect having a negative result while telling the truth, and the third suspect, and so on and so on and so on. Until, well, only until the 5th subject. Okay. So notice I was using the word and, right? The first subject having a negative result while telling the truth, and the second subject, and the third subject, and the fourth subject. So and means multiply. So the probability should just be 0.90 times 0.90 times 0.90 times 0.90 times 0.90, or 90% raised to the 5th power, which is 0.590. Okay, well, that's pretty close to D, so I would choose D.